For decades, supply chain planning ran on a slow, monthly schedule. It was a rhythm built for an era where buying a product meant physically visiting a store and handing items to a clerk. The shift to instant e-commerce and fast delivery quick commerce broke those rigid spreadsheet-heavy models. Consumers expect items to be available within hours, outstripping the capacity of 30-day planning cycles. When static forecasting misses a demand surge, shelves empty out. Whether it's a sudden supply disruption or a miscalculated trend, these severe stockouts mean consumers walk away and revenue is permanently lost. Overcompensating for that risk creates the opposite problem: massive overstocking. Warehouses fill with dead inventory, tying up capital and inevitably leading to expiration, obsolescence, and extreme waste. Surviving modern retail requires replacing monthly guesswork with agile, multi-layered AI-native engines that ingest thousands of data points to predict and react to demand in real time. The foundation of this system starts with a rigorous train and test validation cycle. The AI splits historical sales data, generates a forecast on the first half, and tests its accuracy against the second. To find the most accurate prediction, an evolutionary genetic algorithm rapidly tests over 30 distinct statistical and machine learning models, like ARIMA and XGBoost, for every single product in every specific location. This diagram illustrates winner takes all. The engine runs 30 algorithms, automatically filtering them to select the model with the lowest error percentage. Alternatively, the ensemble approach weights outputs from the top 3 models, blending them to stabilize the final forecast. By automating model selection, this mathematical baseline strips out human bias, establishing a statistical foundation for the forecast before real-world variables are introduced. Historical data alone cannot account for the fluctuations caused by human-driven events or sudden environmental shifts. Planners feed the system controlled variables, like upcoming price changes, massive seasonal discounts, and targeted marketing campaigns. It then incorporates external drivers. The AI automatically maps historical sales data against uncontrollable cultural events, like festivals, to anticipate demand spikes. It also measures the correlation strength of localized events, calculating how a major football match impacts demand for snacks in that specific city. It even factors in public weather data, calculating whether an incoming temperature spike will directly drive up the sale of cold drinks or specific moisturizers in one region while remaining irrelevant in another. By modeling these internal and external causal drivers, the AI accurately separates the product's normal baseline demand from event-driven sales uplifts. To manage short-term execution, the platform deploys a demand sensing module. This shifts the operational focus away from monthly horizons down to a localized, daily, or even hourly level. This module captures high-frequency market signals. It intelligently switches between traditional push-based logic for month-end targets and dynamic pull-based sensing for rapid e-commerce orders. This daily agility is critical for products with ultra-short shelf lives, like fresh ice cream, balancing stock levels to maximize fulfillment and minimize expensive spoilage. We see the same necessity with baked goods. The system dynamically generates daily replenishment orders based on current inventory positions, preventing the loss of freshness. This creates the physical reality of modern supply chains: rapid, automated fulfillment guided by precise, dynamically updated daily forecasts. Shifting to real-time sensing allows brands to react instantly to sudden market shifts, bypassing the limitations of outdated, frozen planning periods. The platform also features specialized logic to handle blank spots in the data. For new product introductions, it uses like mapping, comparing new items to similar existing products to estimate sales and calculate potential cannibalization. It also deploys out-of-stock imputation. If a product was out of stock due to a supply failure, the system detects the artificial dip and fills in the lost sales, learning from true demand. Once the data is clean, it enters the sales and operations planning layer. Here, organizational hierarchies, from regional managers to national heads, can review and collaborate on the AI's math in a centralized digital environment. This diagram shows dynamic aggregation. Manual forecast changes at the national level automatically disaggregate downward across regions. However, if overrides fall outside mathematical tolerance bands, they instantly flash red, warning the team that the numbers defy statistical probability. This consensus layer allows human expertise to guide the strategy, while ensuring that gut feel decisions are rigorously scrutinized against mathematical reality. To execute these plans, the platform integrates its forecasts directly with major ERP systems like SAP and Oracle, and ingests flat file inventory snapshots from major e-commerce marketplaces. It also provides explainability and genius analytics, turning complex data into readable post-action reports. Planners can perform detailed forensics on the system. They can look back to see exactly why the algorithm selected a specific model, or uncover the precise variables that caused actual sales to deviate from the projected plan. Soon, a GenAI integration will streamline this entirely. Planners will be able to query the system using natural human language, instantly generating deep analytical reports and complex scenarios without touching a spreadsheet. The synthesis of dozens of algorithms, real-world signals, and human expertise transforms demand planning into a predictive science.